Namaste and welcome in this session of problems on the Z transform. Before we proceeding for the problems on the Z transform, let's devise the definition of Z transform. As we all know, for the general discrete time signal x of n, the Z transform is defined as the summation of x of n into z raised to minus n, where n is taking the value from minus infinity to infinity. This expression is considered as a bilateral Z transform. Here the Z is the complex value variable and it can be expressed in the polar form as r into e raised to j omega, where r is nothing but the magnitude of Z and omega represents the angle of Z. We also have the representation of unilateral Z transform, which is defined as summation of x of n into z raised to minus n, where n will take the value from 0 to infinity. In this session, we will discuss the Z transform of the sequence, some sequences along with the ROCs. So here, the first sequence that we are having is x of n is equal to e raised to n u of n. So by the definition of Z transform, we have x of z is equal to summation of x of n into z raised to minus n, where n is taking the value from minus infinity to infinity because we are using the formula for the bilateral Z transform. Now upon substituting the value of x of n, which is here is nothing but e raised to n u of n, we get the expression for x of z as shown over here, that is nothing but summation of e raised to n into u of n into z raised to minus n, where n will take the value from minus infinity to infinity. So here we know u of n is nothing but the unit step sequence which will exist from n is greater than 0 and its value will be 0 when n is less than 0. So by substituting these values of u of n for the in the equation 1.1, we can have the x of z as in summation of e raised to n into z raised to minus n, where n will take now the value from 0 to infinity because u of n is equal to 1 for n is greater than or equal to 0. Now taking the n common from the power of a raised to n and z raised to minus n, we can rewrite x of z as in summation of az inverse whole raised to n, where n will take the values from 0 to infinity. Now for x of z to converge, this summation should be less than infinity. That means the summation should be finite. Okay, so that is only possible when the magnitude of az inverse is less than 1. And for such case, we are having the mathematical expression. That means if this condition is existing, then by using this mathematical expression which give us the value of the summation for the term which is less than 1 having the power n will be equal to 1 upon 1 minus y. Okay, here y is the term which is less than 1. So therefore by using this mathematical expression and this condition, we can write the x of z, that is the Z transform for the given sequence, is equal to 1 upon 1 minus az inverse. Now this equation 1.4 also gives us the information regarding the ROC, because ROC is generally the range of the values of z for which our x of z become finite. So from equation 1.4 we can say that the ROC here is the range of the values of the z for which the magnitude of az inverse is less than 1, because for these values only this summation will become finite. Or in other words, we can say the magnitude of z should be greater than a, which will be nothing but our ROC. So the complete representation of the Z transform along with the ROC for the given sequence is nothing but x of z which is equal to 1 upon 1 minus az inverse, and with the ROC equal to all the values of z, magnitude of z, which are greater than a. Now, how we will plot this ROC? For plotting this ROC, let's consider a z-plane whose x-axis is represented with the real values of the z and y-axis is represented by the imaginary values of the z. So here, what we will do, we will draw a pole of this x of z. So for this x of z, A is the largest pole that we can have. So we will plot that pole over here in the z plane, and then we will draw a circle whose radius will be equal to a. Now according to the ROC which we have got, it is stating that it is the ranges of the values of z for which the magnitude of z should be greater than a. So the values of z which are greater than a are outside this circle, and therefore the whole region outside this circle in the z plane is considered as an ROC for the given sequence. So this is how we can plot the ROC for a sequence which is generally the right-sided sequences. Okay, because here you can clearly see that a raised to n u of n is generally the right-sided sequence because it is existing from 0 to infinity, because it is existing towards the right side of the plane. So over here, let's move on to the next problem. Here you can see the next problem is x of n is equal to a raised to n u of minus n minus 1. So here by definition of z transform, we can write x of z as in summation of a raised to n u of minus n minus 1 z raised to minus n, where n will take the value from minus infinity to infinity as you are considering the bilateral z transform expression. Now here u of minus n minus 1 is nothing but your left-sided sequence which will exist from minus infinity to minus 1. Okay, so its value will be 1 from minus infinity to minus, when n is equal to from minus infinity to minus 1, and it will be equal to 0 when n is greater than minus 1. So by considering this definition, we can express x of z as a summation of a raised to n z raised to minus n, where n will take the values from minus infinity to minus 1. Now taking minus n common from the power, we can rewrite x of z as a summation of a inverse z the whole raised to minus n. Now let's consider this minus n is equal to m. So when n is equal to minus infinity, m will be equal to infinity, and for n is equal to minus 1, m will hold the value 1. So now let's write x of z, that is equation number 2.3, in terms of m. So therefore we will have x of z is equal to summation of a inverse z raised to m, where m will take the value from 1 to infinity as we have discussed earlier. So this particular term, this particular summation, we can even write in more convenient form. For that, let's consider, let's add and subtract the value 1. So here, by adding and subtracting value 1, we can rewrite this 1. Okay, in this equation, this 1 we can represent as in 0th power of az inverse, a inverse into z. Okay, so over here, with this term along with this summation, we can consider, by combining these two terms, we can write these two terms as in single summation of a inverse into z raised to m, where now m will take the value from 0 to infinity, as we have included the 0th term for this summation, 0th power term for this summation, and this minus 1 will be considered over here. So therefore this term, this complete summation, we can represent as in summation of a inverse into z raised to m, where m will take the value from 0 to infinity minus 1. Okay. So now for x of z to converge, we should have the summation less than infinity. That means the summation should be finite, and that is possible only when A inverse into z magnitude should be less than 1. So by considering this condition and the formula that we have already discussed earlier, this mathematical expression, we can write x of z is equal to 1 upon 1 minus A inverse z. Okay, as the here term A inverse z is coming into the picture. So for this summation, we can write this expression, that is 1 upon 1 minus A inverse z, and this minus 1 we are considering as it is. So now further simplifying this term, we will get x of z is equal to minus 1 upon 1 minus az. Okay, so now over here, this particular condition which is mentioned over here in 2.5 equation is also giving us the idea about region of convergence. So here the region of convergence is nothing but the ranges of the values of z for which A inverse into z magnitude should be less than 1. So that means in another word, the magnitude of z should be less than A. Okay, the value A. So therefore, the complete expression for the z transform of the given sequence along with the ROC is nothing but x of z is equal to 1 upon minus 1 upon 1 minus A z raised to 1. And the region of convergence will be the values of z where the magnitude of z will be less than magnitude of A. So the plot for the ROC will be nothing but the area inside the circle whose radius is equal to A. So for that, what we will do, we will plot the smallest pole of your x of z, and you can draw a circle, and the area inside that circle will be nothing but your ROC, because here we are considered all the values of the z which are lesser than A. So this is the magnitude of z should be less than A, and this is the area. This is the area where the values of z, magnitude of z will be lesser than A. So you can self-try this these problems for finding out the z transform and the ROC of the given sequences by considering the method that we have discussed earlier. Thank you.